Question: if 9 to the power x minus 1 divided by 3 to the power x plus 1 is equal to 8, solve for x. Since 9 is equal to 3 squared, we can write the given equation as 3 to the power of 2x minus 1 is equal to 3 to the power of x plus 1, and the whole thing is equal to 8. If we write 3 to the power x is equal to y, and we substitute this value in the previous equation, we get y square minus 1 divided by y plus 1 is equal to 8. Or y square minus 1 is equal to 8 multiplied by y plus 1, and that is equal to 8y plus 8. Now bringing everything to one side, we get y square minus 8y minus 9 is equal to 0. This is a quadratic equation in y, and it has two roots. The roots are, by using the general formula for quadratic equations, we get y is equal to 8 plus minus root over 8 square minus 8 into 1 into minus 9 divided by 2 into 1. That is equal to 8 plus minus square root of 64 plus 36 divided by 2. And since 64 plus 36 is equal to 100, the square root of that would become 10. So y would be 8 plus minus 10 divided by 2. So the two roots would be y1 would be 9 and y2 is minus 1. Since we have taken the substitution of 3x is equal to y, we get, corresponding to the two roots we just now found, that 3x is equal to 9 or 3x is equal to minus 1. The first equation gives 3x is equal to 3 squared, because 9 is equal to 3 into 3. Comparing this equation to two sides of this equation, we get x is equal to 2. Examine equation 2, that is this equation. 3 to the power of x is equal to minus 1. Please appreciate that irrespective of any real value of x, whether positive, negative or 0, 3 to the power of x cannot assume a negative value. For example, if x is equal to positive 3, then the left hand side would become 3 into 3 into 3, that is plus 27. And if x is a negative number, let us say 2, then 3 to the power of minus 2 will be 1 by 3 to the power of 2, which will be plus 1 by 9, still a positive number. If x is equal to 0, then 3 to the power of 0 is equal to 1. So in all cases, positive, negative or 0, the value always becomes positive. But these are for real values of x. How about imaginary numbers? Are you familiar with the Euler's identity, which is considered to be the most beautiful equation in mathematics? The identity is e to the power of I pi is equal to minus 1. Remember, I is equal to square root of negative 1. This you must have known from your study of complex numbers. Again, Euler's identity is e to the power of I pi is equal to minus 1. Marvel how two transcendental numbers, that is e and pi, are transformed into a real number minus 1 by an imaginary number, that is I. Coming back to the present problem, we can write from equation 2 that 3 to the power of x is equal to minus 1 and same minus 1 is equal to e to the power of I pi. Therefore, 3 to the power of x is equal to e to the power of I pi. Taking the natural logarithm of both sides, we get x logarithm of 3 to the base e is equal to I pi. Because on the right hand side, it is e to the power of I pi, and if you take the natural logarithm of that, it becomes only I pi. Hence, the second solution is x is equal to I pi divided of logarithm of 3 to the base e, or the natural logarithm of 3. Check that this solution satisfies the given equation.